Good afternoon, everyone who's here. Welcome to our session on Everyone Can Code. I'll just give people a couple of minutes to join, or a minute and a half to join, and then we'll get started if that's okay with you. And we'll hopefully rattle through this in record time. I've set aside an hour, but it might not take that long. We'll need to wait and see. See a couple of familiar faces there. Jim McLean, hello Jim. Kevin, good to see you. They'll be giving me a report at the end of this, you realise. I'll get emailed a score out of 10 or something. Jim will keep me right. He'll tell me where I went wrong. Won't you, Jim? And he's on mute, so keep him on mute. Do we need to have our iPads handy? No, you don't really need to know. I wouldn't imagine you need them. If you want to, then by all means feel free, but no. Thank you, Tony, for that question. Okay, I think I'll get started then. Okay, welcome everybody. My name is Michael Conlon. I am a transformation consultant for XMA, and I have to hold my hands up and show that I have got some invested interest in this particular area because my background is computing science, and I was a computing science teacher and head of department for, oh goodness me, 18, 20 years or something like that. So clearly I'm a fan of coding, and that really started about when I was about 14. I thought it was 13, but it was actually 14. When my dad got me a Spectrum Plus for my Christmas, and I know we could do the big battle about Spectrums versus Commodore 64s, and maybe if you had, you know, Atari STs, if you were one of those lucky ones. But I had a Spectrum Plus, and it was really funny because last year, and my dad died about 10 years ago, but last year I found this here. It was a guarantee registration card for my ZX Spectrum Plus that my dad hadn't filled in, hadn't sent off actually. He'd filled it in, so it was nice in his handwriting, and it reminded me of that journey that he helped start for me, which has obviously led me here many years later, more than 40 years later. No, 30 years later, yeah, more than 30 years later. Here I am, still talking about coding. Very passionate about coding for a whole host of reasons. Mostly to do with that feeling you get when a program works, and I wanted the young people I work with to have that experience of feeling, that they had conquered a problem, they've solved it, and that they've made something happen. They got rid of the bugs and the logic errors, and it was detached from. I think it was kind of detached from how I felt when I solved a maths problem. I think it was because it was a physical computer, that it was me that was controlling what happened. And that was a very special feeling to have, and it still exists to this day. When I was teaching and I solved a problem, I always felt amazing. But there's a whole host of reasons why we're going to look at coding. So I'm going to run through a quick presentation with you. I am going to look at some of the resources that Auric says. Jim had an Auric computer way back in the dark days, Jim. And so we are going to have a look at the resources that Apple provide and how you can use those. Really rich, really supportive resources, and then take your coding journey with your young people into the future. So I'll switch my camera off. I will present my main screen. Sharing, show main screen. There we go. There's my presentation. I hope you can all see that. Everyone can code with Apple and XMA. So we're going to look at the Everyone Can Code platform from Apple. It's like a really engaging and simple platform to attract users into coding, young people into coding. I'm going to take a deeper dive on this with the iPad. Apple really believe that every student should have the opportunity to create things using the kind of lingua franca of our society and the way we do things. That's through coding, because software is integrated into every single part of our lives, the way we work, the way we learn, the way we socialize, and that's becoming increasingly so. And it's not just about COVID, and that's led to a whole host of digital integrations and digital focuses in the last few months. But this has been happening all around us everywhere we go. So it's something that Apple strongly believe in, that if we're to give everyone a fighting chance, then coding should certainly be part of the learning environment that they grow up in. And there's a whole host of coding resources out there that we use in Scotland and I know across the UK, a bit beyond just Apple's Everyone Can Code. And Apple understand that there's a whole supportive ecosystem there, but they've got a kind of best-in-class solution for this. One of our favourites when I was working at Education Scotland was the Barefoot Computing resources, which are broadly broken down into those 3 ages and stages, and developing some of the skills and their understanding in and around computing science and computational thinking. So it's an excellent site to go to. All you need to do is register, and you'll have access to all the lesson plans, and especially some of their great unplugged activities. We'll talk about unplugged later on, but there's some great resources there. There's obviously the Code Club, there is the code.org resources, if you're interested in that. There's the Scratch resources, but I want to take us and focus on Everyone Can Code, developed by Apple. This is a curriculum. So they've built this curriculum in consultation with real people, teachers and young people and experts in the field. And they've produced a set of resources that cover age 10 plus upper primary school. Starts with Everyone Can Code, and there's 2 books which are completely free for you to use. Age 10 plus, 45 hours worth of lessons for each one of these books, and a 45 to 60 minute per session. So there's lots and lots of content there out for you and available to you.
If someone said, and when you're older, do you know how to code? Like, we're going to expect you to know how to code.
That's a really interesting statement, isn't it? When people ask you, they're going to definitely want you to know how to code. He's taking that at face value, but that's absolutely the way things will go. I just jumped to a different part of this slide deck here. Pull that up. Sorry, moved too quickly onwards. And so what you get is these 2 books, the puzzles book and the adventures book that are for students, and there's also a teacher guide, and that's really, really supportive, leads you as a teacher all the way through the curriculum, and that 45 hours worth of content. I would also encourage kind of independent and collaborative working on these. Developing a shared skill set and working with others is really, really critical. Software teams of one are really rare these days, and as a teacher, I would absolutely spend some time on my own going through these books so that I became comfortable with the curriculum. So it's puzzles and adventures with accompanying teacher guide. So you don't need any experience of coding because you're going to be helped through every part of that process. What I'm going to encourage you to do though is to do that learning of code yourself using those materials, because discovery learning sounds like just give it to the kids and discovery learning will make it all happen. But both in practice and in research, there's very little return on that, so not so much. So we've got 2 books to work through. Let me get past all this. That I want you to have a look at. But there's also this Everyone Can Code, Quick Start to Code. Now, what Apple have done just in the last month or so is produce this Quick Start to Code that really is a really good route map through the books, the puzzles book, to help you, find a pathway for you and your class, starting with, stage 1, 2, 3, 4, 5, 6, etc., and work through these activities as a way of progressing through that curriculum. That'll really give you a good grounding in how to make best use of the book. And if I just jump out and show you this, I put a QR code there and the web address. Quick Start Code looks like it's just a PDF you'll walk through, and it takes you through. Here's what each section is of the 10 sections. Go to this playground or part of the book and do these particular activities. When you're doing step 3, go to the Me Bot 2 dances playground and do these activities. So it takes you all through those 10 activities, really straightforward, and then how to keep learning, including the more content within the puzzles book. And if you're not going to do it as part of your formal curriculum and during class time, then you can still use those puzzle books and adventure books through an Everyone Can Code Swift coding club that you can set up for morning, lunchtime, afternoon sessions. So there's a Swift coding club resource there too if you want to use that. So I'll get back to here. So that Quick Start to Code is really the best way to do it. We've got Swift, which is a language which was easy to use, powerful, completely open source. But I want you to know that Swift is a real language. It's not a fake made up one to teach kids how to code. It is a real language which has real applications. It builds the apps, that thousands of applications that you know and you use yourself. And then you can go beyond both puzzles and adventures, and you can go further in when you're in high school and upwards. You can start developing in Swift on the Mac, and then you can move into things like Xcode and further develop your skills there. So this is a really meaty product when you get from end to end. That introduction in puzzles and adventures is really feature rich, full of the really important coding concepts that you need to be able to develop coding skills as you progress through the rest of your curriculum. There is a curriculum guide that you can download using this QR code or that web address, or just search for it. And that'll tell you about how it aligns to standards and assessment approaches, because you do want this to fit into your, your computing science curriculum, or what you've got planned as your whole school development planning around computing science and coding. You will want to know about, is there any support there for the design process, because the coding part of it should be a very short part of building a solution. The design process is absolutely critical, and that's how applications get built and prototyped. And so there are links to resources and guides. So there's a guide about how you can develop your own app you'll find a link for that within the curriculum guide. So how do you showcase an app? How do you build it? They've even given us the Keynote template to help you and your class work through developing and designing their own app. And hopefully by the end of today, I'll show you an app that was produced by a group of children themselves, based on ideas that they brainstormed and sketched and stuff. So there's a whole support ecosystem there for you as a teacher, as a leader of learning, to help you get the best out of the Everyone Can Code curriculum. But sometimes I like to start off, I know Jim will appreciate this, sometimes I like to start off with a bit more of a challenging question to do with coding. And this is really born from a conversation I had at a departmental heads meeting I was at with heads from different subjects all around the local authority, from different subject areas, and just having a really good conversation. And there was a teacher maligning my insistence that as part of the curriculum we should have a computer games course. And the logic of that for him was madness, because not everybody's going to be a computer programmer. You know, there's not enough jobs out there for computer programming. And my argument was, you know, well, lots of children do philosophy, but they don't go on to be philosophers, or they do woodwork, but they don't end up as joiners and things like that. So we have to develop the whole person and give them experience of subjects which are related and connected to how they will live their lives. I mean, I would teach everybody to plumb, quite frankly, because, you know, you've got to know what that stopcock is this winter, that's for sure. But I think everyone should code. And I think there's so many benefits to developing a coding mindset. And it really starts off with, excuse me, jobs, sorry. So there are a whole swathe of different job and employment opportunities that come in a new economy, which is software based. And here are some of the jobs here: user experience designers, app designers, social media managers. An understanding of coding or a deep use of coding will be involved in different capacities throughout these kind of jobs. And we do want to help young people secure a future and have a job in the future. So it'd be remiss of us not to make sure that's part of our curriculum. We have a program that allows them to access that. And I think that's critical, but it isn't just about jobs. One of the challenges we have in computing science in particular is the number of women and you know, people of different ethnic minorities. We've got a whole host of people that aren't getting involved in the computing science world. And there's a few of my heroes on the screen there. And Grace Hopper being one, and she's the one in black and white, and Ada Lovelace, of course. And my experience tells me is that as a computing scientist, whenever I've been involved in projects, is that diversity is really, really important. If you've got a diversity of different approaches to problem solving, you're probably going to end up with a better solution. That's been my experience. And I think we should aim to have as broad and as diverse a range of people engaged in computing science and coding as we possibly can. And we can start that journey really, really early so that people understand that coding is for everyone and it's not just for a subset. Because if you get a subset of people who are all fixed in their way of thinking about how coding happens, you usually end up with the same solution every time. And I think variety is really, really important. But the kind of skills you develop when you're developing computing science and coding skills, those are really in demand, and particularly the ability to solve complex problems and the methodology you use in order to solve problems. And that's really what the coding curriculum is trying to do. It's trying to develop those skills through coding. You can develop those skills through other subject areas. Of course you can, that would be ridiculous. You can develop them through craft and design and maths, etc. But this is another mode through which you can develop complex problem solving skills, critical thinking and analysis, leadership opportunities, collaboration, teamwork skills. Those are equally important, and for lots of different jobs, not just to go into computing science. And that's what I was trying to connect with that gentleman about, was like the skills they're going to learn, but the learning coding are going to be applicable in lots of different areas, and not just so as they go in to be a computing science teacher or a programmer or a software engineer. These skills are developing are going to be relevant to them across their entire life and job areas that they want to go into. So let's explore some of that with them. So there are essential skills around creativity, collaboration, and problem-solving skills which really pop out when you go through this curriculum and everyone can code. You see they pop out really, really well, and you'll see that young people can develop the skills using these particular aspects. And for me, as a computing scientist, I'm really interested in how well a program can develop some of these computational thinking skills in and around algorithms, decomposition, patterns, abstraction. These are concepts in computational thinking, which at first, when you first read the words, you go, well, that's nothing to do with me. But when you actually start looking at your own subject area and your practice, you'll actually realize you do this all the time. We're just giving it not even new names. We're just putting it into this coding environment. So decomposition, for example, is breaking down a complex problem or system into smaller, easier to solve parts. And you do that way back in primary one. You know, my wife's a primary one teacher, and she'll talk to children about the steps that happen throughout the day in the school day. We come in, we wash our hands now. We come in, we wash our hands, we get our books out, we do this, we do that, then it's break, then it's lunch. So that sequence of breaking down the day into smaller, more easily understandable parts. Pattern recognition, looking at where you've seen this kind of thing before, recognizing it both amongst different problems and within problems. Abstraction, which is looking at a problem and getting rid of the extraneous noise to just focus on the parts which are really the meat and two veg of the problem itself, and nothing else distracting you from it. And then algorithms, which is that step-by-step solution. What are the steps we take to solve this problem? And if you think about that, if I go into my home economics department, they know all about algorithms, but they just call it a recipe. You know, if I go into art and they're doing an animation, they're talking to me about a storyboard they're building. And if we look at some of those examples, we'll look at some of those examples in a second, they all help develop approaches in and around tinkering, so that's mucking about, fiddling about with stuff to see what works, what doesn't work, creating new things, debugging. And one of the examples we always used to talk about with language like this, like debugging, is getting teachers to use it in other contexts. So debugging is obviously looking at your solution and trying to figure out the bits that are wrong. You can do that in English when a young person hands in a piece of written text, and instead of saying, well, you need to fix your punctuation, maybe you could call it your debugging. You're finding out where the full stops are missing, where the capital letters are missing, where the semicolon should be. You're debugging the text. You're looking for errors in order to make it perfect, if you like. Perseverance is a big thing in terms of developing young people's resilience. You know, when that program doesn't work, are you going to go back and challenge it again? How are you going to solve it? You're going to meet with other people and talk to them and get their support to help figure out the problem. And then collaboration, as I said before, you know, a team of one is very rare in computing science these days. Collaboration is critically important for a diverse range of solution ideas, as well as just the vibrancy that it brings to any project. This is a perfect example here of sequence, about the concept of sequence, and I normally introduce coding using these kind of things with my students. Let's see if this works.
Good morning, apartment. Good morning, doorway. Good morning, wall. Morning, ceiling. Good morning, floor. Ready to start the day. Ah, here it is. Instructions to fit in, have everybody like you, and always be happy. Step one, breathe.
Step one, breathe.
Okay, got that one down. Step two, greet the day, smile, and say, good morning,
The children understand that, don't they? The way they get up in the morning, how they start their day, what sequence they do things in.
3, exercise. Jumping jacks, hit them. 1, 2, 3. I'm so pumped up. Step 4, shower.
So he does his exercise and then his shower.
To keep the soap out of
Or would you
your
do
hair.
the shower first and then exercise?
Brush those fruit. Comb your hair. Wear clothes. Almost forgot.
I'll move on. That's a nice way of introducing these concepts to people. You know, what is an algorithm? So this is an algorithm. It's a recipe to prepare 8 tenderized round chicken fried steaks. It's making me hungry, actually, just looking at it. Or something as simple as putting on a tie. If you follow these steps, you're supposed to end up with that on the screen. But something written in English, is that the best way of describing the process? The algorithm, and there are multiple ways of describing a sequence of events. This is a very popular way of doing it through a storyboard, as I mentioned earlier. This is still an algorithm. How am I going to create this particular bit of film? It involves these particular scenes. You're not including every frame of the sequence. You're hitting the key ones. You're doing some abstraction here. You're getting rid of some of the extra detail. I know many of us will have tried some of these efforts. I just built a table and chair for my wee boy because he's just started school, and it was this kind of diagram. There's abstraction in here. There is still an algorithm for you to follow. There's a language here all of its own, and we should practice this as often as possible, I guess, from a young age, because we will be doing it. And then here's music, you know, a piece of music. That's an absolute abstraction from what it actually eventually sounds like, isn't it? And I don't even know what Vivace means. Somebody will tell me at some point. It's my greatest regret that I don't know how to read music. I can sing all right, but you know, reading it's a different challenge entirely. But it's an abstraction, it's an algorithm. If you follow these steps, you will get this particular tune as thought of in the head of, I'm going to assume it's Anton Diabelli. And then we've got something like this. So you've got, how do you do the waltz? Again, it's an algorithm that uses both text descriptions of how to do it and also a visual description of how to do it. I can't do that, clearly. So I think these kind of concepts are real for people in everyday life, and it's about bringing that to people's attention, I guess. So what I'm going to do is, I'm not going to do a dance. I mean, just using that diagram is not any use. It's a bit like telling somebody to read a book in order how to learn how to ride a bike. You actually have to get on it and actually do it, don't you? You actually have to do the thing and make it happen. So I will come out of here. And what we're going to do now is I'm going to go to the books that we are going to be using. And I'm hoping if I can just switch my iPad on and bring that up. Okay, so here we have, this is my iPad. I'm hoping you can all see that. And within the iPad, I've gone to my library, my book library, and I've downloaded a collection of different books. And the ones I'm interested in really are that everyone can code puzzles. You might notice I'm using a mouse for this. iOS 13 and iOS 14, you can attach a Bluetooth mouse to your iPad as a way of controlling it. If you're not handy with the swiping methods, it's a certain way of doing things. So everyone can code puzzles. This is a later book for further development beyond puzzles and adventures, but there's also the teacher guide that I was talking about. So there's a guide for pupils to follow, and there's a guide for the teacher to follow. And the guide for the teacher to follow has both information for the teacher and also shows you the pages that are in the puzzle guide for the pupils. Okay, so as a brief introduction, in Swift Playgrounds, as we're going to see, is a 3D graphical environment where you give commands to a particular character, and that character will follow those instructions out, as the case may be. And they can create solutions to problems using the language called Swift. Very straightforward. It's 40 to 45 hours of coding. And really what we want to do is to develop young people's understanding of these 4 particular parts. And as a teacher, you'll be familiar with how learning happens and how you would normally do this in a classroom. So we first of all help young people learn the concepts, and usually in an unplugged manner, and that means without the use of a computer. So you'll talk to the children, as you do here, about commands, where they have to learn about commands and what they are, and instructions, and they maybe write a set of instructions using their handwriting, or a recipe, and you talk about those things. So they learn about the concept of a particular computing science element, and then they try it out in the playground, the Swift playgrounds, using the characters that are in the application and the coding terms that you get to use within that. So you try out that concept in this environment. You then apply that skill you've just learned in that particular playground, usually in another playground. So we know how important that is, don't we? You've learned a concept and an idea, you've tried it out, now I want you to apply it in a whole new context. And that's going to demonstrate how well you have learned that particular construct or that particular part of coding. And then the last bit is to connect what you've learned and what you've practiced and what you've applied into the real world that is around you, and think deeply about the interconnectedness of what they see with their eyes every day and how that relates to what they've just learned. So that's the way the book is built up. It's about learn, try, apply, connect, really straightforward. So learn, try, apply, connect, there we go, very straightforward. There's a pacing guide to show you, if you use this book, you're probably going to spend about 3 class periods, about 3 hours, just less than 3 hours, on commands to really get a good go at it and, you know, enjoy exploring their understanding of commands. Then you move on to functions. That'll be 3 class periods until you've got the 45. Now you'll know your kids, you'll know that, you know, some of your kids are going to race through commands and functions quite quickly. You'll know that you maybe don't need 3 hours for each one, but that'll be for every individual teacher, and to be able to do that and make that decision around how much time they spend. But this is the pacing guide they kind of advise you to do it. There's assessment, appropriate assessment techniques to use as you're working through this, all familiar to all of you. There are accessibility features built into this, including things like voiceover, zoom, larger text. There are some instructional videos for Swift Playgrounds and voiceover. You can get a link to those there. There is a tactile worlds that contain tactile layouts that you're going to see in the Playgrounds app. And you can build that and supplement it with the Unified English Braille tools. There's a video center for American Sign Language, and they'll walk you through how to do the different aspects of using Swift Playgrounds. And then we're ready to get started. So the book, I mean, as a teacher, you'll just walk through it, you know, and really, really hold your hand all the way through. There's a little bit of the coding clubs. This is what the pupils would see as this is their part of the book for commands for this unplugged activity I was talking about. So in this particular example, they're going to play hide and seek, and they're going to write commands about how someone else can find that object. What commands would you give them? And that doesn't require a computer. And that might even follow some of the things you've done with them in early years in primary, for example. But still worthwhile doing this from your age 10 up. They'll really understand what's going on. So let's come out of the book here, and I'm going to go to Swift Playgrounds itself. So it's right down here, Little Swift. And what I've got in front of me is, as you can see at the top, My Playgrounds. There's lots of different playgrounds you can play in. You'll mostly work within Learn to Code 1 and Learn to Code 2. Puzzles will be sitting within Learn to Code 1, but you will be asked to use and download other playgrounds like these 2 that I have here, Lights, Camera, Code, Bot 2 Dances, for example. There are more playgrounds for you to get and have a look at, so let me see all of those. So I've got the major ones, the Learn to Codes, etc. Then there's the challenges, which you'll use in different parts of this curriculum, pardon me, and you can have a play with. But then there's other third-party connections, like the Microbit, the BBC Microbit. It's a very popular piece of hardware out there across schools, certainly in Scotland and I know across the UK. And you can use your Swift development tools and skills to program the Microbit, so that you get to see a different context of how you use Swift. Similarly with many of the robots that many people have, like the Dash robot, from favourite of mine, there's the MeBot there, but there's also things like the Sphero, I know, which is a very popular robot out there across the UK, Lego Mindstorms, these little drones, for example. So when you think about the power of Swift to connect with all of these different environments, it means as a teacher, you've got lots of different places to go, to extend, to go down a little avenue with a particular interest from the class, etc., whether that's through the formal curriculum or when you do it as a code club of some description. So that's all the playgrounds available to you. Let me look at the Learn to Code playground. If you're using the Quick Start to Code, the first thing it'll ask you to do is go and look at the commands option within here. So I'm going to go into that playground, the Learn to Code playground, and it's going to walk the young people through this particular concept of commands. Have you ever followed the recipe? Yes, I have. Or instructions? Yes. If you don't follow instructions in the right order, you might end up with something unexpected. So there's this introduction to the coding platform, and then we can get started, start coding. And so what I have here on the screen is a Swift Playground split up into two halves. On the left-hand side, you'll be given information about the goal state that you're trying to reach. What is it you're trying to achieve? Well, the goal here is to use the Swift commands to tell Byte to move and to collect a gem. That's smashing. You can see this nice 3D environment on the right-hand side, and I can use my finger just to rotate that world. I can use my pinch tool technique, to zoom in to this little character who's called Byte. Seems like a nice guy. If I tap on Byte, I'll get the choice. If I don't like him for some reason, I get to choose another character. So if I tap on him, I can choose another character. But Byte is my favorite, so I'm going to keep him, and he'll jump back into the world because he's the one we're going to use. And I can move it around and I can get closer up to see the environment he's currently in. You might just be able to see in the middle of the screen, there's a little slider just here, and I can use my finger to slide that over to the left so that I get to see the full environment that Byte is in. Okay, and I can zoom that around. All very straightforward and easy to use. And then I can just tap on the arrow on the left hand side, there's a little white arrow. You tap on to bring that back into view. So the reason why it's 10 and above is as you move through the book, there is a level of literacy which is needed in order to be able to access what goes on in this this playground, if you like. So that's why it's not suitable for, maybe P1, P2, because the level of language and the new words it uses is just really, it would be inappropriate. There are other solutions out there to support young people in early years, and we can look at that a little bit later. So this is very easy. Look for the gem in the puzzle world, enter the correct combination of move forward and collect gem commands, and press run for my code. So essentially I have to get this wee guy up here. I need to get him to the gem. And I've only got two types of instructions, move forward and collect gem. So if I tap to enter code, we're asking me to enter code, you'll see at the bottom of the screen, what's appeared are the options in the language that I can use. These are the only pieces of language that Byte understands. He understands collect gem, and he understands move forward. So I would use those two commands to get him to that place. So if I was to use collect gem first, for example, well, there's not a gem where he's currently standing, so that would be a waste of time. So I'm going to go move forward, and you'll notice that that immediately puts that whole command in there. I can type in move forward. I could type in move forward if I wanted to. And I could, but what we want to try and do is get children to solve the problem quickly. And if they're spending a lot of time with the syntax and typing each letter at a time, we could end up slowing that process up. Obviously, as a coder, you eventually do have to type in things, I'll tap on that little right hand arrow there, but I could type in move forward. Wouldn't understand it because I spelt it incorrectly, Mr. Conlon. And then I would need an open bracket and a close bracket, like so. Now a little red dot has appeared on the screen where it says move forward there, and that's because it is very strict in terms of the syntax, in that the first instruction move, the second word has to start with a capital letter. So move forward or collect gem, there's the word, and the second word has to begin with a capital letter, and that's really important. So this wouldn't work. The red dot's telling me that. So I'm going to make my life an awful lot easier just by tapping on move forward. So I move forward, move forward, move forward, and then I collect the gem. Now, if I think that's the right solution, then I can run my code on the right-hand side of the window down at the bottom. So if I tap run my code, let's see what Byte does. I've switched his sound effects off, but I can switch them on. Well, he's delighted with himself, look at that. You've written your first lines of Swift code. Great, I'll move on to the next page. You can access the next page by going to this list here, where I've got issuing commands just up here. I can click on that and it'll bring me the list of commands that I'm trying to learn things about. So I might want to move to adding a new command, and I move to a different part of the playground, and I'll get a new 3D environment with new places that I want Byte to move to collect the gem. Although this time what's happened is I've been given a new instruction called turn left. He now knows how to turn left, which is great. One of the things, maybe not at this early stage, is that I get children to spend time understanding the problem. I used to try and get the children to tell me what the problem is before they go ahead and code. Now, at this early easy level, that might seem a little bit trite because kids know how to solve that within a few seconds or whatever. But if we get into the habit of being able to describe the problem first, getting the solution is an awful lot easier. If children understand the problem space and can articulate the problem, then that's a much better way of learning that software development process that they'll meet later on, further on down the road. So we've got 3 instructions here. I mean, it's move, well, how could I do this? In later problems, what I would probably do is I would pull this little slider over, so as I can see the full environment. I'll zoom in a little bit, and I'm going to rotate, well, not like that, I'm going to rotate just a little bit here, like so. And then what I'm going to do is I'm going to do a screen capture. And so I'm going to take a picture, he hopes. I'm going to take a picture of that environment, little screenshot, and then I can bring that up. Because it's just a picture, I can annotate it. And I can use my my markup tools on the iPad to help me solve the problem, rather than trying to keep it all in my head, which we do want to do. We want to use some of that local memory, if you like, for them to hold that problem environment in their head. That's important. But here's another way of supporting them learn about the problem and what has to be achieved. So I might want to use a particular highlighter color just to highlight what the steps are. So he needs to go there, and he needs to go there. He'd need to go there, and he'd need to go here. So that's at least 1, 2, 3. There should be 4 steps in there, shouldn't there? And there's a point at which he has to turn. He has to turn in that direction. So this is me just trying to annotate what I think the problem is. He's got to get those 2 steps. He needs to turn left, then he needs to go there, and then maybe I would highlight that he needs to then collect the gem. So we can use some of the features of the iPad to help us understand and describe the problem space that he's working within. I'll save that to photos and I can use it back later. Swipe back to get my code back. And I can then use that picture to support me as I'm solving the problem, and I'm showing that I'm understanding the problem. So I would go to tap in here. Let me get that back, see if I can get there. This occasionally happens. Oh, brought the keyboard up. That's maybe the quick way to snap it into view. Is here are the 3 commands. So I need to move forward twice. So move forward, need to turn left, and I've got another 2 move forwards, and then I've got to collect the gem. Now you'll notice that byte, doesn't do it very quickly. But so there's some options down here, and next to where it says run my code, I've got a little timer. And then that timer, I can run my code, but I could get it to run fastest, so it'll go really quickly, or I could step through my code line by line if I'm looking for a bug, for example, and it'll just walk through it step by step. So let me just try stepping through my code, and we'll see over here on the left-hand side, there was a problem running the playground. Nobody likes to see that at any point, so let me go and try something different. Let's go see if we can run fastest. Oh, look how quickly I did that. Great job. Fantastic. So, these are really simple problems in that environment, but can you see how much content is here? And by the time you get up to using logical operators, you're well on the way to developing that computational thinking mindset using loops. Kids love loops. When they see how to do loops, they go bananas. And that quick start to code feature that we saw just earlier on, this pathway that they've got, Apple are suggesting from 1 through 10, as I say, is a really nice way of working through these books and other playgrounds apart from Learn to Code. So Learn to Code is a whole, swathe of different ways of looking at the world and solving problems. But there are other environments to do that, other playgrounds to do that with. One of the nice ones is down here, and it is in Lights, Camera, Code. So within Lights, Camera, Code, because I know I'm conscious of the time, let me go with starting with a camera. Here is a set of Swift commands, which look very different from the move forward and turn left that we've had before. This playground I really like because it shows young people about how to use different components to build actual real world applications. So if we look over on the left-hand side here at the code that exists here, let space equals space, let camera equals Swift camera, style shark. I'm going to change that, I think. I'll change that to plain at the moment. And this little panel on the right-hand side is going to do a little bit of the teaching about how to learn how to create an actual application. So with this particular piece of this particular playground, I'm building a camera app, different from the camera app that exists normally on the iPad. But what it does begin to help young people understand is that sometimes language looks a little bit different from the Swift that I was using earlier on. Sometimes there's numbers that have to be plugged in, coordinates. So I need to hold different problem spaces in my head that are different from the spaces that I saw in that playground that Byte was in. So this is really nice. This just walks you through what components are, how you build a camera out of different components. Here is the code that you could type in, I suppose, or in order to speed up your learning process, you can simply just copy that code. If I get rid of this all just now, you'll see. And I cut that code out. I can simply go over here and copy that code snippet, and then over here I can click on paste. Hold my finger down, choose paste. Oh, not delete, that's the wrong. Paste. I've done it again. Excuse me, it's because I'm using a mouse. I'll tap in paste. Now run my code. So just these 4 lines of code together, when I run my code, I end up with a camera app, and here I am, live. Same shirt on. This isn't a video. This is definitely me right this moment in time, creating a little camera app. And then you can start to, muck about with some of the components, like instead of that, let me go for a shark camera. And then when I run my code, I've changed an element of this component, like so. And there's the thing that would take the picture. And that would end up in my camera roll. So this is a completely different looking playground, isn't it? I'll stop the camera because it's not doing that. But this nice little sequence of building a collection of code which creates a very small basic app really begins to help young people think about, well, actually, it's more than just moving a little character around the screen, isn't it? It's more, there's something a little bit more real behind it than that. There are robots you can connect. There's me bought 2 dances. Excuse me. If you've got one of these robots, you can actually connect it through Bluetooth to your iPad and see the actual physical thing happening. Now that's often a really useful thing in terms of developing understanding for young people, because they see the physical manifestation of their code happen right in front of their eyes in a 3D space. Excuse me. If you can't afford that, and things are tight, they have given you, this is the robot that you would get, and I've already created a little bit of code in and around dancing, because a dance, as you know from TikTok, from all of you out there that do TikTok dances, and I'm not one of them incidentally, dance is a sequence, isn't it? And dance is an algorithm that when you learn that algorithm, it's really, really impressive. So I've got a little dance that I've got a little me bot to do, and hopefully he'll start doing his little happy dance. And then a greeting. This is still on his happy dance here. He's waving, that's his greeting. And then he's going to move to the right, and then dance to the right, and then dance to the left. And then he's going to do a little swing move, another swing move. This is still part of the swing move, believe it or not. And then he's going to do a twist move. And again, this is a different environment, isn't it? You're actually using commands to control something that would have motors in it. And that small subset of language is really important. When you delve deeper into coding and things like this robot here, and you start designing and building your own functions and procedures so that you can teach it new commands beyond just this twist, swing, move to left, right, greeting, and happy. You can teach it new commands, and that's where the power of program really takes off, when you can start defining and creating your own instructions for this robot or any other robot to do. So what I would encourage you to do is to use that quick start to code for yourself, first of all, right? Go and have a play with this document, which you'll find online, Quick Start to Code from Apple, and walk through these different environments that you have here, these different playgrounds, and learn how the Swift programming language really can build confidence over time about using code and the real world applications that exist within it. Don't forget the teacher guide. Those are really, really important. I would always encourage you to look at those for the real depth and the detail moving forward, and then start playing around with some of these playgrounds, even some of the ones that maybe aren't in that 10. So play around with some of the augmented reality coding playgrounds, really nice challenges within there. Lots to keep you going with, whether it's through your formal curriculum or whether you or your code club or something like that. That may be a good way to get started with Swift playgrounds. I'm interested in developing Swift because I'm a computer science teacher, but using it all the way up to qualification level. And it absolutely can do that, both in the English and the Scottish and the Welsh and Northern Ireland curriculums. That's absolutely possible. So what have we got then? We've got the Teaching Code website. You can head there to find all the information I've been talking about. At XMA, we are Apple Professional Learning Specialists, we are super keen to explore more with schools and institutions and around coding and go deeper than we have obviously gone today. So if you want to find out more and want to get any Apple Professional Learning within your school or establishment or local authority, please don't hesitate to contact us at this very address or phone number, and you can check us out on Twitter as well if you wish. I'll just pop myself back on, stop sharing my screen. I do hope you managed to get something out of that today that maybe you weren't expecting, and that you enjoyed the session. There's lots of resources out there. I'm going to see whether I can maybe get this presentation to those attendees. That would probably might be nice for you to use. You know, I'm not precious. You know, go ahead and give you the links to those places that are useful to you. So thank you very much. Don't have any questions. We've got maybe a couple of minutes for questions if anybody's there. Thanks, Jim, for your good feedback. Always really appreciate that from you. A fellow computing scientist, hi, well, Steve's there as well, fantastic. It's really important that we get beyond and past this, the plumbing algorithm. I think young people connect to coding really, really well. It exists in and around the world that they live in. The world's built on software. We can't escape it. So if we can't escape it, the best thing for us to do is to understand it. And I think there's really a great opportunity with these resources that teachers can really build their own confidence and letting kids loose in these playgrounds. So Steve's asking what age group can start with Swift Playgrounds. So we're looking at probably 10 plus upper primary school. Apple used to have a collection of materials for the earlier years, and I know they're looking at that again in the future, because we do want to support young people on their journey from a very early age on that journey with programming. And for many young people in those early years, you know, primary 1, 2, those kind of things, there's loads of resources out there online. I think I showed Barefoot Computing there earlier on. That's really important. They start a journey in developing that computational thinking mindset, and they can do that with those materials. But the real deep formal stuff can start with the Everyone Can Code stuff from 10 upwards, Steve. Hope that answered your question. Also free apps like Daisy the Dinosaur for the very young. Yeah, there's some great stuff out there, isn't there, Jim? There's Tinker, there's CodeSpark, there's Scratch Junior. There's a whole host of apps within the iPad universe that are really great for starting them on that journey, especially for non-readers. It's amazing how quickly young people pick up how to solve problems despite having no language themselves. They just fundamentally understand that the play part of it gets them involved in wanting to solve the problem, and play is a great primer for engaging with lots of problem-solving activities across computing science. So thank you very much. Can you use the screen reader with the text? Yes, as far as I'm aware, you can use the accessibility features across the iPad. As I spoke earlier when we were looking through the book, the teacher guide gives you all of the links to the accessibility features that exist on the iPad to support the Everyone Can Code curriculum. So it's all there and up for grabs, voiceover, things like that, Steve. So they're all there. And with that, I'm going to, at 4:30, I'm going to say thank you very much for your time and for your attention today. I really appreciate you spending some time with us. Hopefully come and join us for another session sometime in the future. And as I say, if you want to get in contact with us, please do. Thank you very much and have a very good end of your week. Take care. Thank you.